This trial was designed by Chris Hazoffel with the Indian Head Agricultural Research Foundation. It was conducted at several locations, although we're only reporting on the trial site from Yorkton. Our trial site was funded by Grain Millers out of Yorkton. The oat trial looked at three basic agronomic factors. The first factor contrasted early and late seeding dates of May 10th and June the 5th. The second factor compared seeding rates of 200, 300, and 400 seeds per meter squared. The last factor assessed nitrogen rates of 70 and 120 kilograms per hectare. Based on past research from Saskatchewan and Manitoba, our first expectation was for early seeded oats to have higher test weights and yield. How did that work out?
Well, kind of the opposite. The yield of oats tended to be lower with early seeding. While not statistically significant, early seeded oats yielded 4.5% less than late seeded oats. The reason for this was flower blast. Oats can blast when flowering is occurring during high temperatures. Oats, which were seeded later, may have flowered under cooler temperatures and didn't suffer the blast.
Expectation number 2. Increasing N rates beyond 70 kilograms per hectare will not substantially increase yield and will decrease test weights. Did that work out?
Well, sort of. Past research has shown that the yield of oats are optimized between 40 and 80 kilograms per hectare of nitrogen. In our study, yield was significantly increased as nitrogen was increased from 70 to 120 kilograms per hectare. However, the response differed between seeding dates. The yield increase was 15% when oats were seeded early, but only 4% when oats were seeded late. Increasing nitrogen with early seeded oats was really beneficial because it also decreased the level of blast from 27% down to 14%.
Expectation number 3. Increasing seeding rates will increase yield and test weights of oats. Did we get that one right?
Well, we didn't get the yield part. You can see in this figure that increasing seeding rate did not affect yield when oats were seeded late, and it significantly reduced yield when seeded early. This was the opposite of expectation, but again it was related to floral blast. When oats were seeded early, increasing seeding rate from 200 to 400 seeds per meter squared increased blast from 8 to 31% respectively. You also note that the test weights were declining with increasing seeding rate for the early seeded oats. Again, this is opposite of the expectations, and it's probably related to increasing blast. However, increasing seeding rate did increase test weight for the late seeded oats. The reason for increasing seeding rate typically increasing test weight is unclear. It may be related to smaller or more variable seed sizes packing together better, or less space between the hull and the groat. It hasn't been really fully explored. So with the early seeded oats, increasing seeding rate and reducing nitrogen rate substantially increase the level of blast. Here you're looking at two extremes. On the left, we have a lot of blast associated with the highest seeding rate with low nitrogen. On the right, there's considerably less blast with the lowest seeding rate and high nitrogen. In both cases, increasing seeding rate and reducing nitrogen may have increased blast by increasing interplant competition for resources, or simply cause flowering to occur earlier when temperatures were warmer. The blast with the early seeded oats created some very unexpected results. The best treatment, in quotation marks, should have been early seeded oats at the high seeding rate of 400 seeds per meter squared with a modest nitrogen rate of 70 kilograms per hectare. And the worst treatment should have been the late seeded oats at only 200 seeds per meter squared with an excessive 120 kilograms per hectare of nitrogen. Ironically, the best treatment resulted in 22% less yield than the worst treatment.
This study shows that following the best practices for oat production does not guarantee the best results, as environment can greatly influence the outcome. While not supported by this study due to blast issues, early seeding should be recommended because it tends to optimize yield and test weight. While early seeding may not allow for the pre-seed control of wild oats, it does help to ensure that the crop is harvested under ideal conditions. This is particularly important since oats treated with pre-harvest glyphosate is no longer accepted by some millers. Increasing seeding rate is recommended to optimize yield and increase test weight. While the opposite was true for early seeded oats in this study due to blast, increasing seeding rates did increase test weights for late seeded oats, which responded more typically without the blast issues. Early seeded oats did significantly respond to N rates beyond 70 kilograms per hectare, but this again was related to high levels of blast with low N. Late seeded oats was less responsive to increased N as expected. However, past studies at Yorkton have found oats can be responsive to N rates much higher than typically applied by producers, but this only occurs if lodging is not an issue.